Hello guys, I am Ellis, your host. Today we will be going over programming homework number 9 for Computer Science 2. We're given 3 questions, which I'll briefly go over right here, and then we'll jump right into the code. So we're given 14.7 lab, which is a Fibonacci sequence, 14.8 lab, which are all permutations of name, and 14.12 lab, output a linked list. I'm not going to go too much into detail because we will read about them going over here to our zyBooks. So first up on our list is the Fibonacci sequence recursion. The Fibonacci sequence simply means to add up the previous 2 terms to get the next terms. You always have to have like the first term in order to find out. So like it shows here, Fibonacci so our first term is 0. The second term would be the sum of the previous 2 terms. So we don't quite have 2 terms, but for example, if we have these 2 terms and here's a third term, right? Previous 2 numbers, 0 and 1. You add those together, get you 1. 1 and 1 get you 2. 2 and 1 get you 3. 3 and 2 get you 5, and so on and so forth. So kind of the gist of the thing, or kind of a little small explanation of it. So we were given complete the Fibonacci function, which takes in the index n, returns the nth value in the sequence. Any index value should return -1. So we went ahead and created our Fibonacci sequence right here, saying that if any number is below 1, return -1. If any number is 1 or 0, return that specific number, else run the Fibonacci sequence. As you see here, we had a value which is or variable which is start number, which takes in an input that would be the number or the index value that we would like to find out what the value is. And then we have this print function that says the Fibonacci has a little special format, which the first place value would be start number, which is the index where we want is, and then the actual value because it runs it through our function of Fibonacci. So we'll go ahead and run this with 7. As you can see here, I ran it previously, but it does say Fibonacci of 7 is 13. As we see here, Fibonacci of 7 is 13 is correct. We'll go back over here to see if it gave us any other examples. No, they use the same thing. So far so good. We submitted it and did pass all of the tests that were put on it. So everything seemed to be working fine. And with that said, let's move on to our second question, which is 14.8 lab, all permutations of name. So they want a recursion, write a program that lists all, I'll just read this, sorry. Write a program that lists all the ways people can line up for a photo, all permutations of lists of a string. The program will read a list of word names, then use the recursive method to create and output all possible orderings of those names, 1 ordering per line. When the input is Julia, Lucas, Mia, all separated by spaces, the output would be all the ways we can organize those 3 names in a line. As you see here are all the permutations of those names. So we will hop right into it. So we define our function right here, all permutations, taking in the perm list and the name list. So the name list will be here, and the permutation list will be the list that we create with all the different ways we can organize that line, okay? So the size will be the length of the name list, which we will take down here. Name list will be our input that we will split into. So name list will be the input we split, so that way it is in a list instead of just one string. We also declared perm list down here as an empty list and called forward our function all permutations, which I'll keep on explaining. So if the size of our list is 0 for I in range, or for I in range len of perm list, print perm list I, and what this does, it simply prints out what our permutation list row by row. As you can see up here, it just prints, because we will be adding to our permutation list as we go using this else statement right here, because as we know, the size of our name list will not be empty. It will initially be full with the names we inputted. So it simply just does this at the end so it can print out each name in our permutation list, or each order that the line will be in our permutation list. So I'll explain this else. It simply takes in the names, it copies it to the permutation list, appends name to the new perms, then it gets really confusing on here, but in any case it just organizes these names differently as it goes by each time. So with that said, we'll try in these names right here, and we'll also try in different names to see if it'll work. So I'll input Julia, Lucas, Mia, and it should look like the same list we have right up here. So I'll run the program, and sure enough, these match what we have right here. So seem to be working. We'll run it with maybe 4 names. So we'll put Julia, Lucas, Mia, and Tom to see if it should create a larger list, just because there are 4 names, so there should be more, should have a larger permutation. And like we assumed, it is a larger list because with 4 names you can arrange them in various different, or many other ways I should say. Okay, we'll submit it just so that we could see that we did pass this zyBooks. So 10 out of 10, everything worked out with a different name that they inputted in. So far so good. Finally, we'll jump right on to our last and final question, which is write a recursive function called printList that outputs the integer value of each node in a linked list. Function printList has one of the parameters, the head node of a list. The main parameter reads the size of the linked list, followed by the values in the list. Assume the linked list has at least 1 node. So if our input is, the first input is the size of our list, then these inputs are just the values in our list. So we said the list size is 5, so we did 5 inputs, right? So it should print them out just like this: 1, 2, 3, 4, 5, just how we have them right here, but separated and all in one line. So going into this class was already made, and practically what it does, it just, so it goes ahead and creates our list for us and puts it in an order. And then what we did is we created this recursive print list function here so that it will take each node as we see it and go ahead and print it. So if node does not equal none, node print data, print list, it'll just get the next one in the nodes right up here. So it'll print 1, then go to the next. So I won't go too much into detail, don't want to confuse, but I will input the same thing they did up here and go ahead and run it. We will also try with different values ourselves and see if that works. So sure enough, it printed out the output we wanted, which is right up here. So I'll go ahead and run this program. We'll say 6 inputs and we'll give random numbers, or we'll go backwards: 6, 5, 4, 3, 2, and 1. Since we inputted that we have a list that is six digits long, or there's 6 digits in that list, we gave the 6 digits right here. We'll run the program. It should print them out right here, just like we put them. Perfect. So everything seems to be working. I'll go ahead and submit this just to see that we did indeed pass all requirements. And sure enough, we did right here. As I said, or I'm not sure if I said this earlier or not, but I do have these coded in PyCharm as well, which I will upload to my GitHub page and will put them down below. So you'll find the links below to my code, or to the code that was written here, if you want to use or have any use for them. With that being said, thank you guys so much for watching, and we'll catch you in the next one. Thank you. Goodbye.